Today on This Old House, I go to welding school to help make some goals for our backyard ice rink. It's amazing how much of a touch it really takes.
Yeah. We're gonna try to update this entire house with 3 different types of insulation.
And we'll no longer need these to heat this building.
That's it. Hey there, I'm Kevin O'Connor, and welcome back to This Old House and to our project here in Saratoga Springs, which has undergone a pretty dramatic transformation over the last few weeks. And look at the back of the house now. I don't know if you remember what this used to look like, but our architect described it as a collection of carbuncles, a bunch of additions that had been added to this house over the last century. Well, those were all taken off, and we got this. Down on the first floor, this is a big, wide open family room. And that was made possible in part by a bunch of steel that was flown in. And now a wall of glass looking out onto the backyard. And then up on the second floor, we have got matching bay windows. Those are part of the primary suite. Now those were all built traditionally, stick frame by Matt and his crew, including their roof lines. But as you go to the front of this house, that roof line was changed with the use of trusses. Those were flown in, laid all out, and it actually raised the ceiling height of the third floor, which is nice, but also steepened the pitch of the gambrel roof, giving this house a completely new look. Now down here, we're gonna have a driveway, so there's gonna be a little entrance here onto Evan and Whitney's unit, so you can get into that family room, but then there's gonna be a second entrance right here, and this goes into a mudroom, which will allow you to get into Evan and Whitney's unit, but also into Susan's, which is the second unit this house has. Driveway here, you can see Matt and his guys have prepped for the new siding with the rain screen, because the new claps are going to weave into the old claps on this house. We're trying to save as much of the original fabric as we can, and when we can't, it's an opportunity to upgrade, which is what we're doing with the electrical service. Now keep in mind, we've got 2 units here, and both are getting new heating systems, and they're both getting air conditioning for the first time, plus new appliances, so a lot more electricity going to be drawn into this house, and so it's time for that upgrade. Stephen, good to see you again.
G'day Kevin, how you doing?
I'm doing all right. So you've done a load calculation.
Correct. We did a load calculation and we found out that with the new appliances and the new HVAC systems that it has increased the load to just over 200 amps, which means we now have to go to the next size service. So going from 200, we're now going to a 400 amp service.
Gotcha. Okay. So walk us through how the whole system works. I mean, obviously overhead wires are from the utility, right?
Correct. This is a utility line. We call it a triplex. It comes to this insulator up there, which is called a point of attachment. From that point of attachment downstream is the consumer's responsibility. Okay. So that is what we're upgrading to 400 amp.
And what was here?
So it was existing 200 amp, and you can see the utility line came in, goes into this cable here, which went downstairs to the meters and panels.
Gotcha.
If you want to take a look at this wire over here, so this was the 200 amp wire that was coming in.
On the side of the house. And what does the utility wire look like in comparison to that? Have you got that right here?
This is the triplex that comes over to the point of attachment.
So very similar, 3 aluminum conductors, but look at that. The utility wire is even smaller than the one that was on the house.
Correct.
Okay,
Correct.
And then you're upgrading to what? Because that's a much bigger looking wire right there.
Correct. So what we're going to come down to the meter can with is this wire. This is 500.
Whoa, look at that right there. So that's our new 400 amp service.
400 amp service. Correct.
Copper and much bigger as well.
Yes.
Okay, so you said on the house is your responsibility. When does the utility upgrade their overhead wire?
That's on the utility company to decide whether they want to upgrade that triplex. In the 30 years that I've been working, I haven't really seen them upgrade it that often, unless it's damaged.
Wait a second, you're telling me that, if I got these right, that we have to use this, but they can still use this? How's that possible?
Well, there's a couple of reasons. One is they have their own set of codes, which they follow their own standards. And also, it's outside, so it has air movement around it that keeps it cool, and it doesn't run through any structure. And it's nice and high, so people aren't going to get in contact with it.
Okay. I feel better about it now. And so then we've got 2 new meters, one for each unit, right?
Correct. Then we'll be running our 200 amp cable from the meter down to each panel.
Right, 2 service panels because we've got 2 units in here.
Correct.
Service panels
Correct.
right here.
As we did, we changed a lot of the wiring in the house. Remember, we had that BX cable from before to the new NM cable, and installing new circuit breakers, including new arc fault protection.
Level of protection that's pretty common nowadays with the electrical code.
It's by code, it's required on a lot of branch circuits that we need to put arc fault protections on certain circuits.
All those breakers right there. Okay.
And then the next thing that we're installing as well is surge protection.
Oh yeah. Right.
So whenever we have something maybe like a lightning strike or some the grid's changing switches and it sends a large voltage down the line, that voltage could damage appliances or equipment inside the house. So what we do is we install a surge protection, one at each panel, so it protects the entire installation. And what this does is sees the voltage as it starts to creep up, and then it starts to conduct and disperse that voltage down to ground, therefore protecting the building or the equipment.
And protecting every single one of the circuits right there.
Correct.
Beautiful. Okay. Well, you're off to the races. I'll let you get back to it and get out of your way. Thank you.
Thanks, Kevin. See you, mate.
We are up here on the 3rd floor of our building, and when we first got here, there was an original furnace, just about no electricity, gravity, and it barely heated this building. But that's not what we're doing here, right, Joe?
No, hey Richard, we're actually going to put a cold weather inverter heat pump in this house, and the technology that we have, many people have seen over the years, are these high wall evaporators, and they hang on the wall. It's the same technology that was put into these units that we're actually going to use here, but it looks a little different.
Not everybody likes to see these on the walls. They like to see invisible in the ductwork. So here's our air handler right here.
Yep, so we've got a heat pump air handler that has you know, a larger coil than typically you would see to give more efficiency to the system.
All right, so air is going to come up across it and be either heated or cooled and come out through here.
Right.
Now, can this handle how cold it gets here in upstate New York?
Yeah, it actually can. These units are designed to handle about -10 and still maintain about full capacity, heating capacity.
It's really almost hard to believe, isn't it?
Right.
Yeah.
And you know, occasionally it does drop below, not that we see that -10 very often, but occasionally it does drop.
I think I felt it when I was here skating a couple of weeks ago.
Yeah, actually it was. I think it was -12 that morning. Right. But there is a bolt-on accessory here that is an electric heat strip.
That's great. So that sits in the airstream.
Yep, sits right up on this unit.
Just snaps onto the top. And it all wires in perfectly. So now you've got the air coming up. Gets heated or cooled, a little bit of extra if needed right here.
Yeah,
Good.
so that can turn on when it gets too cold.
All right, so that's not going to stay right here though. You got to put this into place.
Yeah, this unit is actually going to sit in this small closet space. We're gonna have some sheet metal here, and we're gonna run a return down from up in the attic area. It's gonna drop down on the support box, and then this unit will actually sit right on here.
Yeah.
So the air will flow from that return back up through, and it's going to actually go out to 3 zones. We're going to use 3 zones with this system. We're going to heat and cool the 3rd floor. We're going to heat and cool the 2nd floor, and we are going to heat and cool the master suite.
So this will do the upper portion of the building. How about the lower half?
On the 1st floor, we're going to use a very similar unit, and it's going to have the same technology, but it's going to upfeed through the floor on the 1st floor, yeah.
And these will be powered by?
These are going to be powered with inverter-driven compressors, which we've got outside, so let's go take a look.
Cool. So not a small unit.
No, Richard, you know, these units come in all different sizes, and for this particular project, you know, they're sized accordingly.
You need enough heat for that -10 degree day.
Yeah.
All right, any special rules?
Yeah, so we've got some rules to follow. One, I would say first is snow. Anticipated snow level, so we've got this up on a bracket.
Yeah, you don't want this to be buried underneath snow.
No, correct. And one of the other things too is, you know, the air is going to be discharging out this way, so we don't want to block the airflow.
Get it up, let the air come out this way.
Yeah, correct. And then the other thing we tend to think about is the wind. You know, put some wind baffles on
if you need it.
If it's windy, yeah.
All right. So this is not going right here, though, right?
Yeah, right, Richard. These are actually going to go out back alongside the house once they get things finished back there.
All right. Well, I think it's getting cold enough that we should start thinking about getting them hooked up.
Yeah.
All right. Thank you, brother.
Hey, Matt.
Hey, Kevin.
So we got a window going in?
Yeah, gonna put a new window in. After you and Paul had moved this frame wall during the demolition and framing stage, we had a window that was in this space, and Susan wanted to try to save that old glass. It has the wavy glass in the double hung window. So we're gonna try to remove one of the sashes and then turn it into an awning window.
Centered over the sink, I presume, right?
Centered over top of the sink, that's correct. The kitchen layout dictated where we were gonna put this from the sink location, and then we raised the sill up to meet just above the backsplash.
I like it. Cool project. Well, I'm here to help.
Let's go. So we had a double hung unit, 2 sashes. This thing's ready to come out of the frame right now. We've already started taking it apart, and we're gonna have to do a little bit of alteration to reuse this sash. There's a bevel on the bottom of it.
Oh, yeah.
We're assuming it's a little bit out of square, but we have this maple over here. We're gonna recreate a new window frame.
Nice, okay.
So this has been drying from when they took the tree down out front.
Cool.
It's ready to go.
All right, well, let's get this thing out of the frame.
We're gonna have to knock this raised edge down with the sander. We're looking for about a 3/16 reveal all the way around.
Nice. That flush. I like it already. Look at that.
Yeah, this is great. So I appreciate you making this. This is gonna be a great mock-up to be able to illustrate how our sill's gonna come in here. We have this extra trim block on that's a bit wider than the pieces we used before. This will hide the hardware and allow us to still get our weather stripping into a groove. That way, when the window comes in, it'll snug up nice and tight, keep that cold air out in the winter nights.
I love it. Good luck. We got to save Susan's old window, which is nice.
Yeah, I think it's going to be a hit when she comes in here to the sink, be able to see out the old window, and we got to salvage the old tree, so
What's not to like?
it's a win.
Good job, Matt. Well done. Our homeowner, Evan, works at a nearby public high school. And one of his students, Francesco Del Gallo, also spends his afternoons at an affiliated trade program where he's learning how to weld. Evan asked him to weld new goal cages to finish off the backyard ice rink at the project house.
All right, well, I got the old goal here.
Okay. So that's what we're going to replicate?
Yep, so this one is tubular. This one's also tubular, but it's made out of pipe. So it's gonna hold up a lot better than this old tubing.
This is the new material.
Yep.
Oh yeah, that's a lot thicker. You can tell that that's a beefy piece of metal right there.
Yeah.
Francesco wasn't always planning on becoming a welder.
I wanted to be a marine biologist, so my plan was get certifications in scuba diving, which I'm level 2 certified, and then go to college to go for marine biology. And then I started doing welding, and I was like, maybe I could go into underwater welding, but then that was super dangerous. And then I started doing welding more, and I slowly was like, I really like this. There's just so many different doors it opens. Like, you can do art, ironworking on bridges and stuff like that. I definitely feel like it's my sort of niche. I feel like I belong here. It's kind of like my passion, welding now. All right, so you need your welding beanie. This is gonna protect your hair from sparks. I don't want to see you running out of here with your hair on fire.
My hair always looks like it's on fire, but I get it, and I appreciate the concern.
Next thing you need is your gloves. Protect you from the heat when you're welding, because that's gonna be the closest thing you have to the weld.
Got it.
And the last thing you need is your helmet.
Yes, sir.
This is gonna protect your eyes from the bright light that's coming from the weld.
How's that?
Yep.
So what'd your parents think when all of a sudden you pronounced college was out and welding was in?
My mom was totally okay with it. My mom wants me to do whatever I want. And then my dad was like, he started hearing all this stuff I was doing. He's like, I think I'm okay with this. Like, he wasn't too worried about it. So before we do the goal, we're gonna do a simple fillet weld in the 2F position, so that's horizontal.
So fillet weld.
Yep.
Literally gonna fill between the base and the top here.
Yep. I'll demonstrate first.
Yep.
And I'll have you go.
Well, what's your day like?
Well, I go to my home school, Chalmont. Halfway through the day, I drive here to BOCES, do some classwork.
So, talking about building a reputation, this is a good way to do it. All right, to go there, represent yourself, represent our program, and continue to build your reputation as a welder.
And then we go in the shop and work.
So as your day unfolds, are you getting excited when you get in the car to start driving to BOCES?
Yeah.
You are?
Yep. like counting the minutes, because I feel like here I've made friends that I'm gonna like that are gonna be my lifelong friends. Let's take a crack at it. Perfect. Try and get a little bit more on that bottom plate. Yep. That was good, man.
Well, it's definitely messier than yours.
Yeah, but that's for your first time. That's really good.
It's amazing how much of a touch it really takes. You
Yeah.
know, you really kind of got to get a rhythm. You got to be super smooth and controlled.
Yep. So right here, it's pretty much picture perfect. You know, perfect speed, nice uniformity. Right here, it's convex, too slow.
Doesn't mean it's building up.
Yeah, so you're just going too slow. It's building up.
So what do you think the plan is for you 3 years, 5 years out?
5 years out, I'm hoping to have my own business, at least like start it up, and then like I'll still have like a part-time job, and then I'll be working with the business on the side as well, like just to start out, and then eventually I want to have like a very wide business that's making a lot of money to the point where I don't need to work part-time anymore.
Mm-hmm.
You ready?
I'm ready.
So let's get this thing together.
See if I can do this without ruining your goal here.
Perfect.
That good?
Yep.
Okay, so we got a little bit more filling in to do. You want to put the bottoms on right there, but that's pretty cool. You're a good teacher.
Thank you.
You're a good welder, but you're also a good teacher.
Yeah. For your first time, you're doing pretty good.
All right, thank you, Franny. Appreciate
No problem.
it. I'm gonna keep working a little bit here.
Yeah.
You keep yelling at me. All of our mechanicals have been roughed in. Plumbing is in the ceiling and the floors. You can see that the electric is right here, and it's all been inspected, which means we can start buttoning up the house with board. But before we do that, we have to insulate, and that starts in the basement. Hey, Matt, so a 158-year-old house with a little bit of everything in it, you know, between the rubble stone foundation, new construction, old construction, not easy to insulate and get it right.
No, it's been tough. Little everything in this building. So we're going to primarily throw 3 insulations at this. It's going to be a closed cell, an open cell, and a blown-in fiberglass.
Right, so now you got to decide what to use, where to use it. So closed cell is, if I recall correctly, one of the most expensive. So you got to really decide why to use this and where to use it.
Yeah, it is more expensive, but a closed cell is going to have a higher R value per inch on the yield. That's going to help out with putting less material here to obstruct anything else. And when we blend this up into the rim joist, it means I don't have to collapse this entire bay where we might run mechanicals or anything else, as well as this is a vapor closed system. So I don't want any of the moisture that's going to be laden in the ground coming back through the concrete.
Okay, so this is white. I'm used to seeing it yellowish. Did you paint it?
Yeah, so when this was blown out, we went back over top of it with an intumescent paint. So this is helping for our fire rating to make sure that this won't burn so quick, and it gives the inhabitants a time to be able to get out of the building before there's an issue.
Makes sense, because it is not covered down here. Okay, well, let's see what you're doing upstairs.
So we're in the kitchen area here, Kevin, which is all newer construction. We got a dimensional 5.5 inches 2x6 wall here.
Yep.
This is going to allow us to be able to put an open cell spray foam through the entire stud cavity. Nice. It'll fill up behind the blocking, behind the box, and around the wires. And you can see we've taken the posts and the plumbing and brought them to the interior side to make sure the insulation goes around all of this and really fill this entire cavity right out to the face.
Nice.
We don't have to worry about the vapor like we did with the basement because we've dealt with that on the exterior with a control layer.
So perfect application for open cell.
Yeah, open cell is going to work really good here. Over here, we got this party wall. This is separating Susan's side from the main house. So we've put this mineral wool in, and it's gonna go up here and help us with the flame retardant between the two units.
Does code require a party wall be protected from fire?
Yes, it does. We could achieve that by putting a horizontal wood block in, but this mineral wool also serves a second purpose, flame spread and the acoustic separation.
Oh, right.
So it'll be really nice for the living situation to be able to stop any of that noise disruption coming from one side to the other.
Okay. And she's got a whole different insulation package over there, right?
Yeah, totally different thing going on Susan's side. So quite a bit different on this side, Kevin.
Oh, yeah.
We got no open stud bays here. We have plaster and drywall up, which makes it quite a bit different.
Crack plaster, but plaster all the same.
That's right. So we're going to use a thermal imaging camera. This is going to sense infrared temperatures. So we're going to be able to see what's happening in the wall, like X-ray vision.
Do you have any insulation in these walls? Do you know?
We know that there's a little bit. We can see because of the balloon frame and different spots, like looking up from the basement and a few open bays from the upstairs. We could see that there was insulation in some bays and not in others.
Okay. So the camera's going to tell us where it is and isn't?
That's right. It prompted us to get the thermal imaging camera out and be able to see what voids might exist in the wall.
Any over here? What are you saying?
Yeah, we definitely see some changes in temperature over here.
Oh, yeah.
And it's pretty dramatic in some spots.
Right.
The base right now, because they've already started the spray foam, is getting a lot more consistent around the rim, but we still want to be looking out for variations of color and make sure that we can seal this wall up and get it as uniform as possible.
Okay. And so once you've identified your cavities, your voids, how do you rectify them?
So we have the blowing machine that's outside, and we're going to fill that hopper up with loose insulation that'll bring it all the way through those hoses and to the location of the bays that we're going to blow it into. We're feeding the end of that hose down into the stud bays, and as the cavity fills, we'll backfeed the hose, filling the entire cavity with insulation and move bay to bay.
So hopefully that'll give us insulation on Susan's side of the house, and then you've got the whole insulation package that you described over there. When that is all done, are you guys ready to start putting up board?
Yep, we're going to start hanging the drywall, mud, tape, and then we're going to move on to finishes.
Beautiful, which entails what?
Flooring, trim work, the rest of the siding, some of the more ornate things that are going on the outside, and we're ready to start wrapping it up.
I like the sounds of that. We're a turning point on the job. All right, well that's coming up next week. So until then, I'm Kevin O'Connor.
And I'm Matt Whitbeck.
For This Old House here in Saratoga Springs. Next time on This Old House,
we'll bring these chalkboards back to the original luster in this newly restored 1898 schoolhouse.
Today we're putting in new sewer and new water for the next 7 generations here.
This is lead.
Look at that, huh?
Here's the lead joint that adapted onto galvanized steel.
And we'll install a new slate hearth for a gas fireplace.